don't tell me what to, how do I put this? Don't give me the numbers. Tell me what I want to do big picture wise to get this little sliver of the area. Yeah.
Find the area of the triangle and the area of the sector and subtract.
Perfect. Yeah. I just want to get the area of the sector because we know how to do that. I want to get the area of the triangle and I want to subtract those two. Could someone tell me how to get the area of the sector? Gracie.
X over 360 times pi squared.
Mm-hmm. X over 360. So that would be 90, right? So we'd have 90 over 360. And then you said times pi r squared. Well, our r is 10 squared. And then you said subtract the triangle away, right? So can someone tell me what's the area of the triangle? Or how do I come up with the area of the triangle? Yeah, Mary. 1/2 base times height. What's my base on this one? What's my height on that one? Ooh, crazy. And if you do that whole thing, you're going to end up with, I just left it as the full answer of 25 pi minus 50. Just look on the test. All right, if I give this question on the test, I'll either say round your answer to the nearest tenth, or if I don't put anything, I'm expecting this, or if I say leave it in exact form, then you know to leave it like that too. Okay? If you rounded it right now, that's okay, as long as you knew how to do these steps. Okay, now I want to find the arc length. The arc length is going to go pretty quick. So I found the area of the sector. Can someone tell me what's the only difference between the area of the sector formula and the arc length? There's only one thing that switches out. Yeah?
You use circumference instead of area.
Yep, I used circumference instead of area. So here I used area because I wanted everything I filled in this sector. This one I want to see how long does it take me or how far does it I have to travel, so I'm going using circumference. So that's the only difference in this one. So we have 90 over 360 still, because that gives me the how much of the circle I'm being taken up with our degree, times, and circumference is 2 pi r, so it'd be 2 times pi times 10, and that's going to be 5 pi. All right, just for the sake of this being area, maybe we'll put centimeters squared, just so we get used to putting some kind of unit squared on there. I didn't ask for it, but if I do give you a unit, I do expect you to square that unit to let me know its area. All right, any questions on area or arc length? So this area actually covered two sections that we covered. Just coming up with the area of the sector and coming up with the area of this segment. So this could be two possible questions that could be answered just knowing this one thing. And remember, if you're not sure what the area of the triangle is, like you're stuck on finding the area of the triangle, just put in your work like, hey, I know this is the area of the sector. I know I need the area of the triangle, but I don't know which is the base and which is the height or something. Okay, questions from the homework? Yeah. Number 16. I believe I'm open to the wrong page. It was like 58 or something. All right, number 16 says a pentagon with sides 3 meters, 4 meters, 5 meters, 6 meters, and 7 meters has an area of 48 meters squared. Find the perimeter of the similar pentagon whose area is 27 meters squared. So that means, let's do it above. Let's go ahead and do it above that question. Okay, so the first thing I want to do is I want to get that scale factor. I want to know what is one side to the other, because once I know the scale factor, that's actually my perimeter factor as well. Okay, so the way we're going to do that is we are going to know the area of one is, I covered it up, didn't I? Is 48 meters, and the other one is 27 meters. So the area ratio is going to be 48 over 27, respectively. Can I simplify that at all? Is there a number that goes into 48 and also goes into 27? It's not terrible. Yeah. 3 goes into it. How many times does 3 go into 48? 16? Yep. And it goes into 27.9. The only reason why I want to simplify it as far as possible is can someone tell me how do I get the scale factor knowing the area ratio, Gracie? It's going to be 4 over 9. 4 over 3, yep. You got me. You got me to say it though. So our scale factor is going to be the square root of 16 over the square root of 9, which equals 4 over 3. So my scale factor is 4 over 3. And remember, if my scale factor is 4 over 3, the ratio between our areas of the two, or our, not areas, but our perimeters, is going to be 4 to 3 as well. So to come up with the perimeter of our other one, it's just 3 plus 4 plus 5 plus 6 plus 7. So that'll be 10 plus 10 is 20, 25 meters. So the perimeter of this pentagon is going to be 25 meters, and that's the bigger of the two pentagons. So our perimeter, if I'm looking for our perimeter, it's going to be 25 meters over, we don't know the size of the other one, is going to equal 4 over 3, and we just use cross multiplication. Is that good? Okay. Other questions? Yeah. 11. Is that up here? 11 says LMN are midpoints. Okay, so this one we have to go kind of two directions. First we have to draw the picture. We have to use a little bit of intuition. And then we're good from there. So we have a big triangle, and then we have a smaller triangle that's basically the midpoints. So let's go from area and then go down to scale factor, okay? How much area is being taken up from this little triangle? How much, if I pull this out of the big triangle, how much of the big triangle is missing? Just intuition-wise. A quarter. This is a quarter the size of our entire big triangle. So that means our area ratio is going to be 1 to 4. This triangle is 4 times bigger than this triangle. So then let's go to scale factor. Well, the scale factor is going to be the square root of 1 over the square root of 4, which equals 1 over 2. So the perimeter is going to be half, and each of the sides is going to be half as well. All right, so sometimes we have to start with the area. Even though we want to start with the scale factor, sometimes we have to start with the fact that this is a quarter of my area. I'll start with that, and then go down to my scale factor. Does that make sense? In the big scheme of things of life and liberty and the pursuit of happiness. Okay, other questions? 12. The length of two similar rectangles are x squared and xy. Well, you got to just do it. You got to just do what they tell you to do. All right, the length of two similar rectangles is x squared and x over y respectively. So that means their scale factor is x squared over xy, which is actually x over y. So that means our area ratio is x squared over y squared. So you have to put down what they tell you. Don't complicate matters. All right, other questions? Mary? 14. So 14 is find the ratio. Name two similar triangles and find the ratio of their areas. Find DE in both of them. Okay, so our similar triangles in number 14, I'll try highlighting them, are going to be ACD and then we'll do BED. Alright, so now we have to look for, this is basically a similar, it was kind of like when we did similar triangles. I'm going to find two sides that are complete, and I know we're in both of them. So if we look at ADC, I'm going to put that one on top. So ADC is going to go on top. Maybe I'll write that right here. ADC is going to go on top, whatever I find for ADC. And whatever I find for did I say ADC? So AB. E will go on the bottom. So our scale factor, so we got that down. No, stop that. Okay, so our scale factor is going to be, we're putting ADC on top, so it'll be 10 over 9. So that's our scale factor. Maybe I'll put that on the right side. So scale factor is going to be 10 over 9. And I want to get this full length. So I got the scale factor. I want to get this full length compared to this full length. Well, that's going to be 20 over 10 plus, I don't know that length, so we'll call it x. Alright, so we'll have 20 over 10 plus x has to equal our scale ratio of 10 over 9. Now I do cross multiplication to solve it. That's about all the time I have for questions. If you have more, please come see me and check the answer guide to double check. But we went through most of the difficult ones. Everything else is the same. Just come up with your scale factor, and you might have to convert it to a ratio. All right, so yesterday we dealt with things that are just similar in shape. So similar triangles, similar polygons, everything had to be similar. Today we're going to talk about what if they aren't similar, but they share certain characteristics. And these are more prevalent in triangles. Okay, we're basically talking about triangles. So the first thing we're going to talk about is, what if I have two triangles that have the exact same height? They have the same height, but they have different bases. If they had the same height and same base, they'd be the same triangle. But this one has the same height, it just happens to have a different base. So what we're looking for here is the area. I'm looking at the area and the ratio of the area, let me get that up, of triangle ABD over triangle DBC. So I have ABD, so it's the green one, or the green one up here, and yours is just all shaded in. And then there are the triangles here. We can note they have the exact same height. All right, they both reach the same point, but they have different bases. One has a base of A, one has a base of B. So if I'm doing the area of ABD, that's that one on the left, I'm going to do half my base, which is A, times my height, which is H. For DBC, I'm going to do half my base is B in this one, times the exact same height. But when I put them on top of each other, we're going to note that the h's cancel, and the halves also cancel. So the area is just the ratio A over B. So if two triangles have equal heights, then the ratio of the areas is, and what I did here is I put it's base 1 over base 2, just as a little note to myself. And do I look better? And so it's just the ratio of the bases. So if two triangles have the same heights, the only thing that can be different between the two are their bases, so you're only concerned with the bases. Alright, let's use some intuition in the next one. If they have the same base, what do you think we're comparing if they have the same base? Take a wild guess based upon the one we just did. It's rough. Yeah.
Height.
We're going to be comparing heights. This is actually going to be the ratio of the heights. And let's just confirm that. So this is going to be the ratio. We'll work backwards on this one. So we'll kind of pretend like we're making a hypothesis. I'm hypothesizing that based upon the fact that the same heights was the ratio of bases, I'm thinking that same bases must be the ratio of heights, which would mean, so we're working backwards, it'd be height 1 over height 2. And let's just double check to make sure that's true. So once again, I'm looking at areas. And I'm comparing this big triangle to the smaller one. They have the exact same base. They obviously have different heights. So we're comparing the areas of ABC, triangle ABC, over triangle ADC. All right, triangle ABC is going to be half of my base, which is B, times my height, which in this one is H. And my other one is half the same base times the height, which is K in that one. Bases cancel, 1/2 cancels, it is H over K, so it's definitely the ratio of heights. Are these similar triangles? No. Are these similar triangles? No. So if it's similar triangles, we do what we did yesterday. If they're not similar, but they share either a height or a base, we do what we're doing today. So you have to keep that straight, okay? So always ask yourself, are they similar? No. Go to one of these, same heights or same bases. And if they have the same heights, they must have different bases, so it must be the ratio of bases. If they have the same base, they must have different heights, so it's going to be the ratio of heights. All right, 3 quick examples. Find the ratio of the areas of triangle ABC and ADC. So number 1, we have 2 different heights. 2 different heights, so that must mean it has the same bases. So we have same base. What am I comparing if they have the same base? Someone raise your hand and tell me, what am I comparing if they have the same base? Gracie? The heights. All right, so it's just going to be, and we're doing of ABC to ADC. So that means ABC is going to go on top, so that's just going to be 9 over 5. So that's our, maybe I should write that down somewhere. That's our ratio of area. And it's good to know what you're looking for, right? Not just say 9 over 5 because Mr. Pavian says compare the bases. That is our ratio of area on all of these. So we're trying to find that ratio of area on all of these. All right, for number 2, do I have the same base or the same height between ABC and ADC? Same height or same base? Yeah, Sam.
Same height.
It's got the same height, so what am I comparing?
Bases.
The bases, yep. And we're going to do our base of, so same height. So we're comparing bases. ABC is going to have a base of 9. ADC is going to have a base of 16. Yeah.
Does it matter what triangle you put on top? Like which space?
Just because they said the ratio of areas of ABC and ADC, I'm going to put ABC on top and ADC after. All right, it's kind of implied here, just so we're all but you could have flipped it. I mean, the ratio is still the same as long as you just note, like you're just like, hey, Mr. Pabian, this is triangle ADC, and this is triangle. Kind of like I did on here. I would just might put this down. Okay, our last one. Same height or same base? Someone raise your hand and tell me same height or same base. Yeah, same height. They're both stuck at this height here, so same height, so we're going to use our bases. So same height. So we're going to use our bases. ABC is 10. The base of ADC is going to be 12. We can simplify that to 5 over 6. So same bases, use the height. Same height, use the bases. And remember on the test, it's not going to be in its own specific section that says find the height, find the base. All right, you just have to remember. Look for same heights, look for same bases in triangles. All right, so we learned 3 things as of yesterday and today, and these are the 3 big things. If 2 triangles have equal heights, then the ratio of their areas equals the ratio of their bases. If triangles have equal bases, then the ratio of areas equals the ratio of their heights. If 2 triangles are similar, then the ratio of their areas equals the square of their scale factor. So this is what we did yesterday. All right, this was where we found our scale factor. We square the top and bottom, and we go from there. Are region 1 and 2 similar? Think about it. Are regions 1 and 2 similar? So remember, region 1, that guy's a triangle. Is region 2 a triangle? Could they possibly be similar? No, they're completely different shapes. So that's no. And the reason why I wanted to bring this question is because people say yeah on that. Be very careful about what they're asking. So some people will say, well, region 2 is this whole triangle. But region 2 is not the whole triangle. It's just this trapezoid shape or this parallelogram. Can someone name 2 similar triangles that are in there? If region 1 and region 2 aren't similar, what are our 2 similar triangles?
ABC and ADE.
Yep, perfect. ABC. Ooh, let's put triangle in front of that guy. So I know I'm talking about a triangle. Triangle ABC is definitely similar to triangle ADE. So the next one says, what is the ratio of their areas? What is the ratio of their areas? Can someone tell me the first step I need to do to get my ratio of areas, since I don't know either one of my areas? What do I need to find first before I find the ratio of areas? Yeah, Mary. I need the scale factor, which should be just comparing their sides, right? So I'm going to do ABC to ADE. What is the total length of ABC? And don't say 2 or 3. Just shout it out. What is it? What is it? Couldn't hear you. Wow. Is it early or can I? What's the side of the big triangle? What's the side of the big triangle? What's the side of the big triangle? What's the side of the small triangle?
2.
All right. You guys are so excited today, I can tell. So 5 over 2 is my scale factor. So my area, my ratio of area is going to be 5 squared, gentlemen, which equals 25 over 4. That is the ratio of areas. So the next thing says, what is the ratio of the areas of regions 1 and 2? Who can help me find the ratio of areas from regions 1 and 2? No one has an idea? What do you got?
It's just a guess, maybe 2 squared over 3 squared.
2 squared over 3 squared,
Should make it 4
which would make it 4
over 9.
over 9. But are they similar shapes? The only way that works is if it's similar shapes. It was good thinking. It was a good thought. Anyone want to help me, or we'll just make this part of the homework maybe? No? I want to make this part of the homework. Yeah, what do you got?
So since it's like the whole region is 25, and then you have to subtract the triangle to get like the small region, so it's like 21 over 4.
Say that again? So it's the whole?
It's the whole minus the triangle.
Mm-hmm.
So like it's 25 minus 4, which is 25 over 4.
25 over 4?
25 minus 4 over 4.
Is that right? Do you agree with that, Gracie?
Where did we get the 4?
Where'd you get the 4 from?
It's the like ratio, the area of the small triangle in that ratio.
It's the area of the small triangle from that. So see, it's big triangle over small triangle. So she took the ratio of the big triangle minus that area of the small one over 4. So that's our thought on that one. Let's, for homework, think about whether this is right or wrong. Okay? I'm not saying whether it's right or I'm not saying it's wrong. But I want you to go home and just think about that for part of your homework, and we'll discuss it tomorrow. Because that's a good solid question. All right, find the ratio of areas of triangle 1, 2, and 1 and 3. All right, so we're supposed to find the ratio of areas. The ratio of areas. All right, 1, 2, and 3. 1, 2, and 3. Do those have the same height or the same base, or are they similar? It's got to be one of those. Who votes for same height? Who votes for same base? Who votes for all 3 of those are similar? All right, let's do it again because not everyone voted. Who thinks they're all the same height? Who thinks they all have the same base? Oh, we don't have to go any further because everyone voted for height. Yeah, they all have the same height. They all reach that same point up here, so they all have the same height. So they all have the same height. Same height, so that must mean compare bases. Compare bases. So we're supposed to do 1 and 2. So A is comparing 1 to 2. Well, 1 has a base of 8. 2 has a base of 5, and that's it. We're done. B is comparing 1 and 3. Well, 1 is 8. And 3 is 15. Cuckoo, ka-choo. Is something wrong? Oh, okay. Okay, the next one says find 1 and 2. So it says find 1 and 2. Okay. Are these the same height or the same base? Or are they similar? I don't think they're similar. They don't look very similar. Yeah, what do you got? Same base. Look. So if that has the same base, where's the same base over here? So. Region 1 is just this. Oh, okay, yeah, I could see that. So they're not same base, right? They're not same base. Do they look similar? No. Does it look like they have the same height? Do they look like they have the same height? We just need to turn it. We just need to turn it and it has the same height. Because if I drew a line up here, that's the same height for both of them. So they have the same height. So they have the same height. So we're going to compare our bases. Whoopsies. So we're going to compare bases. So that's area 1 to area 2. So that's 7/4. Hey, don't forget, if you're stuck, just turn your drawing. Look how many times that just turning it was like, oh, got it. Right? So turn your drawing. Because when Mary went through her checklist, she probably would have been like, okay, maybe they don't have the same base because one has 7, one has 4. But then you just got to turn it. All right, B. B is comparing 1 and 3. 1 and 3. Do they have the same base? What do you got? They're similar triangles. They're definitely similar triangles. Remember, all we have to do is prove that two angles are the same and they're similar. Well, if I had to do a proof of this, I would say, what kind of angles are these? Let's reach back in our memory. What kind of angles are they when they're vertical angles? And what would this angle be called? These two angles that are opposite sides of a transverse.
Wait,
What do you got, Mary? You got it? Not adjacent.
which one are you pointing?
I'm pointing to this angle and this angle. Opposites of our trans. Alternate interior angles. Alternate interior angles are congruent. So this angle is congruent to that one. We already proved 2 of them, so I could do a proof saying that they're similar. So they are similar. And to go from similar to area, first I need my scale factor. My scale factor is going to be 7/4. And my area ratio is going to be 7 squared, which is 49, over 4 squared, which is 16. Thanks, Bree. Yeah, oh, sorry.
Do that for all of them or just this and
Has to be similar. Has to be similar. Well, and that's why the reason why we come up with whether the bases are the same or the heights are the same. Because you have to do this. If your height is the same, you have to compare bases. If your base is the same, you have to compare the heights. If they're similar, you have to do a scale factor to get to the area. All right, good question. I'm glad you asked that. And you didn't just do them all the same on the test. All right, other questions? All right, let's go ahead and get started on the homework. Remember, your homework does